Hello there, guys. I'm Mr. Rose, as you obviously know, and I'm going to talk to you a little bit about vectors today. Now, overall, we kind of know what a vector is. Vectors we know are essentially represented by things like that, an arrow, where we have two sides of my vector. We have a tail and a tip, which we will get to momentarily, a tail and a tip. And our physics definition of a vector is we know that it is something that has both a size, which is a magnitude, and a direction. So this vector would be, I don't know, let's call it 3 meters per second, and that would be going in the positive direction, or specifically, if I put a little compass here, north, south, west, east, I could say 3 meters per second east. Now that is what we've known so far. Now we also know we can add and subtract vectors. If I said like that was a car and maybe there was a wind going at 2 meters per second east, we know that as a diagram I would draw my 3 meters per second followed by my 2 meters per second. And again, this is just a sketch of my diagram, and then I would know my resultant would be 5 meters per second east, and that would be a velocity because that is a vector, not a speed. Now, vectors represent essentially maps. These vector drawings are maps. I don't care what they are, if it's a velocity, a displacement, a force, an acceleration. Our picture diagram is a map. And today we're going to talk about how we combine them graphically. And by that I mean by drawing either sketches or more specifically using a ruler and a protractor to scale. Now a scale means, a scale diagram is, I'm going to use the centimeter side of my diagram, of my ruler, and I'm going to say, I'm going to say that our scale would be like 1 centimeter equals something like 2 kilometers. So this would be, say, for our displacement. And then we'll say that we walk 5 kilometers east, turn 90 degrees, and walk 4 kilometers north. So my 5 kilometers east, if 1 centimeter equals 2 kilometers, right? I would say starting here, 2, 4, and then half a centimeter there, right there. This is my 5 kilometers east. Now this is one component, and then I turn 90 degrees and walk 4 kilometers north. So I start at the tip of my vector, and I would go, that's going to be 2, 4, that's 2 centimeters or 4 kilometers. 4 kilometers north. And now my question is, what is the resultant displacement? Sorry, that's so sloppy. What is the resultant displacement? So my resultant, by definition, this is something you already know, is my distance from start to finish. So I take my ruler, that's where I started, that's where I ended. I draw my line. Now that's not a vector because it's just a line. I put my arrow there. Now we know there's my resultant. It goes from start to finish. I know I can do Pythagorean theorem, but we're drawing this to scale. And since I use the ruler, all I need to do is measure this, and that is 3.3 centimeters. My line is 3.3 centimeters. Since my scale is 1 centimeter is 2 kilometers, I multiply that by 2, and my resultant is 6.6 kilometers. Now that's just the distance. Because it's a vector map, I need my displacement, my theta. So again, I can use right triangle trig, or I can just use my protractor and I put my protractor right at the end. Now, it's a little bit hard because my protractor is so big and my triangle is so little. So what I could do is I could take my straight edge and I extend it, and look at that. I can see now, you can see that it's right around this line here. Now, is that 40 degrees or 140 degrees? A lot of students make this mistake. I don't actually care what the numbers are. This is how I hold my protractor. Some people hold it like this as well. I put my corner, notice this line right there. That's my starting point. And now my line is at the 90 degrees, and the same thing. Just like a ruler, I'm just going to count my number of degrees. So I'm going to start it like this. I put my protractor just like that. So it's at, that line is at the base. I have that line at 90 degrees. And now I can literally just count. I'm going to go 10, 20, 30, 40. Let's put my ruler back on there, on that straight line. Yeah, it looks like it is at 40 or 41 degrees. So I counted. It is at 41 degrees. Now, how do I know what that is? We are either going to do math where it is 41 degrees in physics tells us a story. That is in this first quadrant. It is up 41 degrees. This is 90. This is 180. This is 270. This is 360. We can always just do that. Just all of my degrees. But that's a little bit harder. This would be at 41 degrees. Or if I'm being specific, talking to a non-physics person, it would be 41 degrees. I went north from the east direction. So right, here's my cardinal directions. There's my little inch, north, south, west, east. I went 41 degrees north from east. So that's all I'm going to do in this short video. This is just a quick input on how do I draw vectors to scale. Thanks for watching. See you for the next one.